Great dear learners. In this video, you are going to watch full paper solving of 9231 Further Pure Mathematics Paper 1. Now, I'm going to solve May-June 2020 9231, which is Further Mathematics Paper 1, Combination 1. 1 we are going to solve. Let's start solving the problem. The first question is, let A be a positive constant. The first subdivision is sketch the curve with equation y equals ax divides by x plus 7. So here we have axis, that is x and y. They have mentioned it clearly divided by x plus 7, so that we are getting one asymptote, that is x equals to -7. So that we can mention that asymptote by the dotted lines, x equals -7. Then next we can find out that what is the horizontal asymptote. So we know the process. In the denominator you can take x as common, so that you'll be getting 1 plus 7 by x. So x and x are getting cancelled, and a divided by 1, that is nothing but a when x tends to infinity, which means 7 by x tends to 0, so that in the denominator only 1 going to remain, and a divided by 1 will give that answer as a. So sum to infinity is a. Y equals to a is the horizontal asymptote. So how we have to draw this? So we can draw them like this. Since we don't know what is the value of a, so simply we can mention any line, that is y equals to a. So that's it. We have drawn these two things. Then we know that the curve is going to approach this vertical asymptote x equals to -7, then horizontal asymptote y equals to a. Maybe we can check that whether the curve is passing through the one and only known point, that is origin. So if you substitute x equals to 0, then you'll be getting 0 divided by 7, that is also 7. So the curve is passing through the origin. So we can draw the curve like this. And here it should go like this, which means it should have these two things. So these two things are the curves. Let's go to the next one. Sketch the curve with equation y equals modulus of ax divided by x plus 7 and find the set of values of x for which modulus of ax divided by x plus 7 greater than a by 2. So now we will be having that axis, coordinate axis. So to draw the curve, so what are the rules we have here to draw modulus function? So the first thing, if the graph is we will draw the asymptotes first. So that is, this is the asymptote and this is the asymptote. Whatever the values are there in y greater than 0, that will remain the same. So this part is not going to get affect, and here after the decimal we will not having any effect. So it can be like this. But this one, previously we had some part like this won't be there, because if y is modulus, so that it will be having only positive values, it will not be having negative. What we will do is we will simply reflect it. So if you reflect it, then you'll be getting the answer like this. Actually, even this one should approach this curve, so maybe you can draw like this. So yeah, we have drawn that. Then next we have to find out the set of values where that modulus value of the curve is greater than a by 2. So first what we can do, we can write ax divided by x plus 7 equals positive a by 2. One of the thing we can take it, that is we can equate it to find out the point actually. So a and a are getting cancelled. Then if you cross multiply them, you will be getting 2x equals to x plus 7. And if you simplify them, you will be getting 2x minus x. Maybe I'm doing the baby substitute, that is equal to 7. Then x is 7 is one of the value. The next thing is we can equate these values with negative, because that's what we will be doing it, minus a by 2. So here a and a will get cancelled, so that we'll be getting 2x equals negative x negative 7. Then if you want minus x, I mean if you move this negative x to this side, it will become 2x plus x equals to negative 7. Then 3x equals to negative 7, so that we will be getting x is negative 7 by 3. So how can you write the answers? 2 points we are having it here, two important points. They are minus 7 by 3 and 7. So now if you check, we'll take one value in between that. That's easy actually. We can put x as 0 here. If you are taking x as 0, we'll check whether it is satisfying or what. If you put x as 0, 0 divided by anything, that won't be greater than a, because they have mentioned it a is a positive constant. So you can see it clearly here. So a will become 0 divided by, actually that won't be, because if it's positive, obviously it should be greater than 0. So this is not satisfying. So it must satisfy here and here. So what are the values? X is less than negative 7 by 3 and x is greater than 7 are the two values which are satisfying. We'll go to the next question. Second question is, the cubic equation 6x cubed plus px square minus 3x minus 5 equals 0, where p is a constant, has roots alpha, beta, gamma. Find a cubic equation whose roots are alpha square, beta square and gamma square. So how are we going to solve this? So the first thing is the roots. One of the common root that we can take that as alpha square, that we can take that as w, because that's what we are going to replace it. Whenever whatever the values they gave, that will be equating with w, then we'll be finding w in terms of alpha in terms of w, so that alpha is square root of w, because square will go that side, it's square root. So the value what we got for alpha, because alpha is the root and we want to find for alpha square. So alpha square's replacement is w, and actually what we have to substitute in the given equation is for alpha is square root of w. So we are going to substitute that alpha equal to root w in the place of x, because alpha is the root. If I substitute, so I will be getting 6 into root w power 3 plus p into root w square minus 3 into root w equals 5. Negative 5 I can move into that side, because that's what I'm going to do. So in this step it's 5 did. And if I simplify this, I will be getting the answer of 6w root w plus pw, because square and root will get cancelled, minus 3 root w equals 5. In the next step, I can keep all the root values one side, and the another values to that, I mean normal values to that another side, I can move it. And the root w terms are having that root w and 3 as common, so that I can take 3 root w as common, so that in this term I will be having 2w as remaining thing, and then here 1 is the balance one. I mean I just factorized. Then pw will go that side, it will become 5 minus negative pw. Now actually there shouldn't be any root values, root w shouldn't be there, it should be like power should be a natural number. That's what the rule, we know that. So that to convert this root w into w or something to that natural number, I can take square. So what I'm going to do, take square or for both sides. What I will be getting here, 3 root w is going to be, I think I can skip all the baby steps and I can do, because if you are a further math student, then it is necessary to know all this. if I take square for this 3 root w, I will be getting 9w. Then 2w minus 1, if I'm taking square, it's going to be a minus b whole square. So that a square, it is 4w square. Then plus 1 square, it is 1, minus 2 into 2w minus 1, it's 4w, equals, even this side also it's going to be a minus b whole square. So if I apply that, then I will be getting 5 square, that is 25, plus pw square is p square w square, then minus 2 5s are 10 pw. Now I can multiply this 9w to the inside values. I mean, I can expand the bracket. I'm getting 9w into 4w square, it is 36w cube, plus 9w minus 36w square equals 25, plus p square w square minus 10 pw. In the next step, I'm going to bring all the terms to the left hand side. So first I have 36w cube, one and only single term, it's 36w cube. Then I have two w square terms. One is here negative 36w square, and right side I have p square w square. So that two terms I'm going to bring into the left side because 36w cube is in the left side. If I bring them, then I will be getting both of them are going to be negative, so that I can take negative as common. If it is so, I will be getting p square plus 36 into w square, because both of them are having w square, so that I'm factorizing that. The next is w term. Here I have 9w, in the right side I have negative 10 pw. If I bring this negative 10 pw to the left side, it will become positive, and w is the only one common term. So if I take, it's actually positive, both are positive, so 9 plus 10p is the coefficient of w. Then only one constant I have, so if I bring that left side, it will become negative 25 equals to 0. After this, we should change all the w cube to x cube, because all the w to x, that's what that required equation, because that equation has been given with the variable of x. So the required equation is 36 x cube minus p square plus 36 x square plus 9 plus 10p into x minus 25 equals 0. So here p remains the same because that is a constant. Let's go to the next subdivision. It is given that alpha square plus beta square plus gamma square. So alpha square plus beta square plus gamma square is sum of roots of this equation. So alpha square plus beta square plus gamma square is, we know that it is negative b by a, and in this negative b by a is, so negative into negative is positive. So p square plus 36 divided by 36 is the answer. And alpha plus beta plus gamma, we can get it from the initial one, I mean the one what they gave, because alpha beta gamma are the equations of it. It's negative p divided by 6 is what we are getting. So alpha plus beta plus gamma is also still remains the same, negative b by a, so that here we are getting negative p divided by 6. According to the given condition, if you equate it, p square plus 36 divided by 36, if you are equating with negative p divided by 6, then first you can cancel that 6 and the 36, you can simplify it, and if you cross multiply, you will be getting the answer of p square plus 36 equals negative 6p. If you bring everything to that single side, then p square plus 6p plus 36 equals 0. We know that this is p plus 6 whole square, so we are getting the p value as negative 6. So we got the value for p equal to negative 6. Yeah, maybe you can square this box also to highlight the answer. That's, you have finished it here. Next we have to find out the value of alpha cube plus beta cube plus gamma cube. Basically we will denote this as S3, and this S3 can be related with the given equation. So the given cubic equation can be related with this, which means x cube can be related with x cube will be related with s3, x square will become s2, then x will become s1, and in the same equation if you substitute it, then you'll be getting the answer. And what we have to do for constant we'll be seeing when I'm solving it. And when I told that s3 is nothing but x cube and s2 is x square, s cube I related with alpha cube plus beta cube plus gamma cube. So you know that what is S2 is. So S2 value is alpha square plus beta square plus gamma square, that is p square plus 36 divided by 36. What is p square? Because it's constant here, that value we need to know. P square is -6. So here I can write that alpha square plus beta square plus gamma square is -6 square, that is 36 plus 36 divided by 36. So I will be getting the answer of 2. So alpha square plus beta square plus gamma square is 2. And this is what S2 is. What is S1? S1 is alpha plus beta plus gamma, that is negative p by 6. Saying negative p by 6 is 6 by 6 and we are getting 1. What is the equation we have, that cubic equation? 6s cube. Oh yeah, you should take that as 6s cube, not simply as s cube s2 like that. It's 6x cube plus ps2 negative 3s1. And what we will do for constant, let's see it. So 6s cube negative 6s2. Why negative 6s2? Because p value is -6, so it's negative 6s2, negative 3x, so it will become negative 3s1, and -5 is the value we have actually. So -5, it should be multiplied with 3 equals to 0. Will be doing it. Why it is multiplying with 3? Because we just have to check what is the highest power we are doing it here. If it's s3, we have to multiply by 3, and if you are doing it for s2, then yes, here the constant should be multiplied with 2. If you are finding for s4, you have to multiply the constant by 4. So just keep this idea in your mind and you just proceed it. 6s cube is the thing you have to find it. I mean s cube. So 6s cube is going to be the unknown value here. Minus 6 into s2 is 2. We calculated it in the previous step. Minus 3s1. 3 into s1 value we got as 1. So it is negative 3 into 1. Minus 5 into 3 is negative 15 equals 0. So now we will be getting 6s cube negative 12 negative 3 negative 15 equals 0. If you add all of them, you are getting answer as 30, negative 30, and if you move into right side, it will become positive 30. S3 is 30 divided by 6, that is 5. Next, we are going to solve the third question. The curve C has equation y equals x squared divided by 2x plus 1. Find the equations of the asymptotes of C. To find out that vertical asymptote, we'll equate the denominator with 0, and we are getting that vertical asymptote as x equals negative 1 by 2. That is a one answer. And for the next answer, we are just checking that either it has oblique asymptote or what. Numerator's power is greater than the denominator. So yes, it has. How to do it? When you divide x square by 2x plus 1, then whatever the quotient you are getting, that is what actually the oblique asymptote is. And if you do this step, because this is very simple division and you can do it, so you will be getting that answer of y equals 1 by 2x negative 1 by 4. So this is the oblique asymptote what we are getting it. So one more time, I'm just repeating. To get the oblique asymptote, divide the numerator by denominator, and whatever the quotient you are getting here, this quotient value you are getting is what the oblique asymptote is. We'll move on to the next one. Find the coordinates of the stationary points on C. So to find out the stationary point, we have to differentiate it and equate with 0. So y value is given as x squared divided by 2x plus 1. Then we have to find out y dash. since it is in that u by v format, so the denominator will become squared, then v u dash, so 2x plus 1 will remain as same, and x square, if you differentiate, you'll be getting 2x, negative x square will remain as same, and 2x plus 1, if you divide it, I mean if you differentiate it, you will get 2. So it's, and if you simplify them, 2x plus 1 into 2x, it's 4, 2x plus 1 into 2x minus 2x square we are getting in the numerator. That can be simplified it further. If you simplify them, you will be getting 4x square minus 2x square plus 2x whole divided by 2x plus 1 whole square. Then y dash value we are getting as 2x square, or 2x is the common, so if you take it, 2x into x plus 1 whole divided by 2x plus 1 the whole square. And we know that to get the stationary point, we have to equate the denominator to the 0. So if you do this, you will be getting the answer. So that numerator is 2x into x plus 1. So 2x equals to 0 and x plus 1 equals to 0. So x equal to 0 and y equal to, sorry, x equal to negative 1 are the two values we are getting. And if you substitute them in the y, you'll be getting the coordinates as 0, 0 and negative 1, negative 1, and they are the stationary points. Next, we have to sketch the graph C. So initially we will be drawing that axis. In the previous subdivision, we have realized that that curve is passing through origin and negative 1, negative 1. Those are the two stationary points. Then also we got it one equation, one oblique asymptote is y equals 1 by 2x negative 1 by 4, and one vertical asymptote is negative 1 by 2. So first we can mark that the vertical asymptotes. So it is going to be negative 1 by 2. The oblique asymptote is negative 1 by 2x negative 1 by 4. So it's going to be like this. So this point is negative 1 by 4, so that you can mention it, and this is negative 1 by 2, and the equation, the curve is going to pass through. So this is the vertical asymptote and it's passing through origin, then after that it will approach like this. Then another part is going to be like this in between these two, and this point you can mention as that point, this one as negative 1, negative 1, because that is that they are the two turning points. You can mention the two turning points to asymptotes equations, then that's it, you have sketched. Next we solve that fourth question by first expressing 1 by r square minus 1 in partial fraction. Show that, so they gave one nth term. Let's solve it. So first step what we have to do is we have to write that 1 divided by r square minus 1 as a partial fraction. So you know that what are the steps that you'll be doing it for the partial fractions, and if you do it, you'll be getting the answer of 1 divided by 2 into r minus 1 negative 1 divided by 2 into r plus 1. You'll be getting it. You might ask me that why can't you do this step, because if you are coming to further mathematics, and this is very basic step and we don't want to waste our time here, because you have to learn a new thing when you are spending time. So if you substitute this, this can be written as summation r equal to 2 to n 1 divided by r square minus 1 is nothing but, so we can write this as summation r equal to 2 to n instead of 1 divided by r square minus 1, I can replace that by 1 by 2 into r minus 1. So maybe if you wish, you can take that 1 by 2 as common also. That's better. 1 by 2, you can take that out. Then you'll be having 1 divided by r minus 1 minus 1 divided by r plus 1. Then now 1 by 2 into, when you're having a two terms and then their differences too, then you can apply that method of differences. So for the lowest value, you'll be substituting the lowest value. I mean, for the first term, you'll be substituting the lowest value two times. So 1 by r minus 1 will be substituted with 2 times, means 2 and 3 you'll be substituting. If you substitute 2, you'll be getting 1, and if you substitute 3, you'll be getting 2 here. So for the first term, if the difference between these two terms are 2, the first term will have these two values, two initial values. The first one is 2 and next one is next value of this, r equal to 2, then 3. So if I substitute that, I'm getting 1 by 1 plus 1 by 2. In the same way, I have to substitute that last two values for the second term. If I substitute, then I'm getting 1 divided by n as answer and 1 divided by n plus 1. If it's last value, you cannot go like n and next value it's n plus 1. Actually, this is the last, so that you'll be going to the previous one, that is n minus 1. And these are the two. In the next step, we can simplify, so that you'll be getting 1 by 2 and 1 plus 1 by 2 is 3 by 2. And here you can take negative as common for the whole, so that this inside negative will become positive. And if you simplify that, the two denominators n into n plus 1 we are going to be the denominator. I mean, I have to multiply the two denominators here, and if we cross multiply it, it is 1 into n plus 1 and 1 into n. If I add it n plus 1 plus n, so it's 2n plus 1, I will be getting it. The next step is I have to multiply this 1 by 2 inside. So 1 by 2 into 3 by 2 is going to be 3 by 4. Negative 2n plus 1 divided by this 2 is going to multiply with that existing n into n plus 1. So it's going to be 2n into n plus 1. And that's it. We have found, we have proved the value what we have to. And in the given one, actually a and b are the two values, but they did not ask us to find out or write the values of a and b. But still, if you feel it, you have to write the values of n, then you can go ahead, you can write very well. Next subdivision is we have to deduce the value of r equal to 2 to infinity, which means we have to find out the sum of infinity. So what we will do, we will be using the previous term, that is 3 by 4 minus 2n plus 1 divided by 2n into n plus 1. So for the second term, I can take that n as common, so that I will be getting 2 plus 1 by n, and divided by 2n square, I can take it, so that it's going to be 1 plus 1 by n. Now I can cancel this n and this n square, and then remaining terms are 3 by 4 negative 2 plus 1 by n divided by 2n into 1 by n, 1 plus 1 by n I will be getting. And you know that if n tends to infinity, then this whole term will tends to 0, so that the remaining thing is 3 by 4. 3 by 4 is the sum of infinity. Sum to infinity. So this is the answer. Let's proceed to the next one. Next subdivision is find the limit as n tends to infinity. So if n tends to infinity, so what is the value? That's what we are going to calculate it. For the changes they made, changes in the upper limit and then lower limit, also they added n in the numerator, so that normal function will get changed into 3n by 4, because that n has been multiplied with numerator. And in the second term, it's going to be n into 2n plus 1, because that numerator is added, whole divided by its 2n into n plus 1 is what the term we have it. Now we have to find out the value of summation r equal to n plus 1 to 2n we have to find. So even in the upper and lower limits of that previous steps also got changed. How are we going to write it? Summation of the initial value what we found for, that is r equal to 2 to the maximum what we have to find for, that is 2n minus, we are going to subtract the values what we don't want or what we added extra. We added r equal to 2 to until n because we want values from only n plus 1. So we are going to remove the values until n. How are we going to do this? So first r equal to 2 to 2n. For that we are going to change the 2n is going to affect only in the second term. So the first term going to remain as same. It's going to be 3n divided by 4 minus in the upper value it is going to be n will become 2n, and this n is going to remain as same because that is a numerator n, and in the nth term whatever that n we have that is going to be 2n will become 4n plus 1 whole divide by this 2n will become 4n and this n will become 2n plus 1. You can ask me why this n has not changed, because that n is added in the numerator as only n, and this 2n turns into 4n. It's because of that limit has changed into 2n. Then this is the first step, this step answer. Then for that what we will be having it negative uh, r equal to 2 to n. It's n is having only the normal value, so that is going to have 3n divided by 4. Then negative into negative, it's going to be positive. Then r equal to 2 to n, I'm going to substitute it. That is nothing but n into 2n plus 1. So why n into 2n plus 1? Because that n exists in the numerator also. So n into 2n plus 1 divided by 2n into n plus 1. So whatever the terms I have, that's what I'm going to use it. Now I'm going to cancel this negative 3n by 4 and positive 3n by 4. They will get cancelled. Then I can write this positive term as first, that is, and also I can cancel the terms if possible. N and this n will get cancelled and this n and this n will get cancelled. So what terms I will be having it remaining? 2n plus 1 divided by 2 into n plus 1 minus here I will be having 4n plus 1 divided by 4 into 2n plus 1. And now I can take n as common in the numerator of the two terms, because I have to find n tends to infinity, so which means I have to find out the sum to infinity. So if I take n as common, it's going to be 2 plus 1 by n divided by 2n into 1 plus 1 by n. I will be having it. After that minus here n, if I take, it's going to be 4 plus 1 by n divided by 4 n. If I take it common, then it's going to be 2 plus 1 by n. I will be having it. Then we know that this n and this n will get cancelled, this n and this n will get cancelled. Then after that this 2 plus 1 by n is going to remain as 2, because 1 by n, n tends to infinity, will give that 1 by n, or whatever that n will give that answer as 0. So that tends to infinity, you can write it. So 2 divided by 2 I will be having it for the first term, and here minus in the numerator 4 and in the denominator I will be getting 8. So 2 by 2 minus 4 by 8, if you simplify them you will be getting that 1 by 2 as answer, and that's what we needed. So the lines L1 and L2 have equations. So they gave the equation, the vector equations respectively. Find the shortest distance between L1 and L2. If you are going to find out the shortest distance, first we need to verify that whether they are going to be skew or not. We can check that clearly they are not parallel. If it's not parallel, and they won't be intersecting too, because if it's intersecting they won't be asking what is the shortest distance is. So it's skew lines. What is the formula we have to find out the shortest distance of skew lines? It's a2 minus a1. They are the point. So if you subtract them, you will be getting a vector that has to be multiplied with u cross v. U and v are the two vectors, and by its modulus or modulus of u cross v also you can put. So if you substitute the values in this formula, then that's it, that is the shortest distance. Now u cross v, how are we going to find out that u cross v? U value is 144 cross, so I can mention by the cross symbol into 0, 5, 6. If I do this, I'm getting the vector of 24 minus 20, it is 4, and for j it is 6 minus, so it's negative 6, and for k it is 5. So this is u cross v, and I can find what is modulus of u cross v. It is square root of 4 square, it is 16, and square root of negative 6 is 36 square, and 5 it's 25. If I add and simplify them, I'm getting the answer of root of 77. The next thing is I should find what is a2 minus a1. a2 minus a1, I have to find it. If I subtract the two given points, 3 minus 3, it is 0. Then 0 minus minus 5, it's going to be plus 5. And actually I have to find out a2 minus a1, but I'm finding a1 minus a2. So if I do it in the reverse way, I'll be getting negative 5, then minus 6 minus 3, it's going to be negative 9. So this is a2 minus a1. And if I find the dot product between this, because you can see that in the numerator a2 minus a1 dot u cross v, if I find the dot product, I will get the value of the numerator as 0 into 4, 0, negative 5 into negative 6, it is plus 30, and the negative 9 into 5 is negative 45. This is what the value I'm getting, and numerator should be positive, or you can even change in the formula that modulus of, because the distance would be negative. If I do this step, I'm getting that numerator value as 15. Then if it's 15, then I can say that distance is 15 divided by root of 77. So that is the shortest distance. We'll go to the next subdivision. Next, the plane pi contains L1 and it is parallel to the vector I plus k. So they are introducing a plane and that contains L1. So L1 means it has the vector of 144, 144. It has vector, and also it has one more vector, because it's for parallel means we can consider that that is also its part of the plane, so that we can write that as 101. And we need to find out the equation in the form of ax plus by plus cz equal to d. We know that r dot n cap or n equal to p. So this is the keyword you have to keep it in your mind. N is the normal to the two vectors. So n is the normal, so that I have to multiply the cross product here. And if I do this, I will be getting the answer of 4 for the I, and for the j I will be getting pass negative 3, but for j I have to change into 3, so it's negative, so positive 3, and for k I'm getting 1000 minus 4, negative 4 I'm getting. So the vector, normal vector, is 4 3 negative 4, and to find out the p, what I have to do, the point of the L1, what is the point of the L1? It is 303. This is what the point, it's 303, has to be dot product, it has to be multiplied, dot multiplied with the n vector, it is 4 3 negative 4, to get the value of d. Here it is p. If you do this, it's 12. Since it's dot product, I have to add them, so 12 plus 0 minus 12, so I'm getting 0 as the answer. It's simple, so p value is 0. So if I write r dot n equal to p, that's enough. And how to write r dot n into this format? So r will be acting as x y z. So if I multiply, I will be getting 4x plus 3y negative 4z equals to 0. So that is the required equation of the plane. Next subdivision is find the acute angle between L2 and pi. So angle between the line and pi. It's simple. We have to find the dot product between the L2's vector and pi is normal, then we have to divide by their modulus and take the cos inverse. Since it is the angle between line and plane, so it's cos inverse. So L2 is, we know it is 0.56, and pi's normal, I mean plane's normal, is 4, 3, -4 in the just previous step we have found. And if you find the dot product, you will be getting the answer of 0 plus 15 minus 24. It's -9. And the modulus of this vector is 0 square plus 5 square plus 6 square into root of this value is 4 square plus 3 square plus -4 square. So let's see what are the two answers we are getting for the denominator. Actually, they are the denominator value and this is numerator value. And here I'm getting root of 25 plus 36, it is 61, and multiplied by here it is root of 41. I'm getting it. Then first, actually, angle between the line and vector, you know that first we will be calculating alpha. Alpha is the component of the required answer. So that how will we get it? It is cos inverse of -9 divided by root of 61 into root of 41. Actually, I should take modulus here because since I want to find out that acute angle, so here I should take the modulus. If I'm getting that alpha value as approximately 79.63 I'm getting. But if I have to find out the theta, as I said before, that is a complement, so 90 minus alpha, and that answer is 10.4 to the 3 significant figure I'm getting. So that's what the required answer. Next question is, they gave the matrix A as 2011, then the transformation in the xy plane represented by A inverse transforms at triangle area of 32 d centimeter square. Find the value of d. So A inverse is transforming, so that first we have to calculate A inverse. For that, if you calculate determinant of A, it's 2 into 1, it's 2. Then A inverse is 1 by 2 into negative, sorry, 1 0 -1 2, you'll be getting it. And if I write as a matrix, I will be getting 1 by 2 0 -1 by 2 and 1, I will be getting it. Then I need to find what is the value of determinant of A inverse, that is 1 by 2 into 1, it's 1 by 2 is the determinant. What change it is going to make, that area is existing area will be multiplied with its determinant, so 30 into 1 by 2 will be getting the answer of 15. We'll move on to the next subdivision. Prove by mathematical induction that for all positive integers n, a power n equals to 2 power n 0, 2 power n minus 1 1. So we have the value of a power 1, that is 2011. We can calculate what is a square is. A square is nothing but 2011 multiplied by itself 2011. If you multiply them, you are getting the answer of 4031. And yeah, so this maybe we can try to write in the nth term, that is 2 power 2 0 and 2 power 2 minus 1, because 4 minus 1 is 3 and it's 1. Let's find a cube, and for a cube what we will do, we will be using that a square matrix numerical values multiply with a again, so 2011. If you multiply, we are getting the answer of 8071. Yeah, this also can be written into this format of 2 power 3 0, 2 power 3 minus 1 and 1. In this way, if you continue, then we will be getting the answer of a power n as 2 power n 0, 2 power n minus 1 1. Now we can check that a power n plus 1 is what. If a power n is going to be n plus 1 is going to be 2 power n plus 1 0, and in the denominator it's going to be 2 power n plus 1 minus 1, and 1 is what the answer. Let's find the a power n plus 1 in the calculation, that is multiplying 2 power n 0, 2 power n minus 1, 1 multiplied by a value, it is 2011. If we multiply, we are getting it is 2 power n into 2, then it is 0 because 2 into 0, 0 into 1. Then 2 power n minus 1 into 2 is 2 power n minus 1 into 2, and plus 1 we will be getting it. Then for this term, 0 plus 1, it's only 1 remains. Then if we simplify and check whether we are getting the answer, 2 power n into 2, it can be written as 2 power n plus 1. Yes, it's 0. Then 2 power n minus 1 into 2, so 2 power n into 2 is 2 power n plus 1, and 1 into 2 negative 2, negative 2 plus 1 is negative 1, and this is 1. Yeah, both are satisfying, so that we have checked and we are approving it. Or you can even write hence proof. Next subdivision is the line y equal to 2x is invariant under the transformation in the xy plane represented by a power n into b, where b equal to 1 0 33 0. Find the value of n. So first I can find out what is a transformation matrix, that is a power n. I know what is a power n is, that is 2 power n 0, then 2 power n minus 1 into 1. Then if I multiply that matrix with 1 0 33 0, then I will be getting the answer as 2 power n 0, 2 power n plus 32 and 0. And according to the given condition, if I am multiplying this matrix with the x and y, the coordinates, they said that invariant line is x and 2x, because y equal to 2x, so y will be replaced by 2x. If I multiply this matrix, I will be getting the answer as 2 power n x equals to x. Then another one is 2 power n plus 32 into x equals to x. So I don't want to cancel x and x on either side, because I have to compare the two equations, so that right side is 2x here, so this side also I can make that right hand side as 2x by multiplying by 2, so that left hand side will have the change of 2 power n plus 1 into x. Now if I compare these two values, I will be getting the answer as 2 power n plus 1 into x is equals to 2 power n plus 32 into x. Now I can cancel the x, because I don't want to find out the value of x or something. I have to find out the value of n. Now 2 power n plus 1 and plus 2 power n, I can move into the left side, that is 2 power n equals to 32. 32 can be written as 2 power 5, because all are in the form of 2, so that I will get a better answer. And in the left hand side I can factorize the 2 power n, can be taken it out, so I will be getting 2 minus 1 as answer. I know 2 minus 1 is 1, so 2 power n equal to 2 power 5 I'm getting, that's nothing but n equals to 5. So the next question is, the curve C1 has polar equation r equal to theta x theta, and for theta is between 0 to 2 pi by 2. The point on C1 furthest from the line theta equal to pi by 2 is denoted by P. Show that at P 2 theta tan theta minus 1 equal to 0. We know that this equation r equal to theta cos theta can be written as r will be in the form of x by cos theta equals theta cos theta. That's what they gave. And here we are getting x value as cos theta will go that side, it is theta cos square theta will be having it. And here we have maybe this can be approached in another way also, y by sin theta, but if you do in that way you won't be getting answer. Maybe you can try that. X equals to 3 cos square theta into cos square theta. So here I can calculate dx by d theta. So because at the point what I can do at maximum, maybe I can differentiate it and I can check the value. So it's theta into cos square theta. First of all, theta into cos square theta, if I'm differentiating it is 2 cos theta, and cos theta if I differentiate I will be getting negative sine theta. And if I keep that cos square theta as the same, so cos square theta will be there and theta will become 1. And now in both the cases cos square theta is common. If I take them out, or negative cos square theta as outside, I will be getting, this term will get into positive, that is actually here you can see that only one cos theta is there. So if I take one more cos theta, it will become theta into 2 sine theta by cos theta it will be, and since I have taken negative cos theta this will become minus 1. And now negative cos square theta into this 2 sine theta by cos theta is tan theta, so I will be getting 2 theta tan theta minus 1. And this is the value of dx by d theta. Suppose in certain cases that theta, I mean dx differentiated value will be 0. If it's a turning point, they didn't mention, but it can be, we are just checking it, it can be. So that if this is 0, obviously that cos is not going to be 0, because cos pi by 2 at the maximum, if they said that it is furthest to that 0 theta equal to pi by 2 line, so theta equal to pi by 2 means theta value is going to be pi by 2 at the time cos is 1 not 0. So this is, there are no possibilities for this cos square theta as being a 0, it's negative 1 actually. So this value must be 0. So 2 theta into tan theta minus 1 equals 0. And that's what we have to prove it. So maybe this has so many directions and we are going in the right direction. Here maybe we can use that y by sine theta, or here why we have differentiated this, because we can't do anything else, so that we are trying it. And this is obvious. To bring this format we are writing in this, and cos theta is not 0, so that we are not taking it, and this can be 0. One more thing is we have to verify that root is lies between 0.6 and 0.7. So first we can write the expression what we got as f of theta is 2 theta tan theta minus 1. And when we are substituting f as 0.6, we are getting the calculator value as negative 0.179. And when we are substituting 0.7, we are getting the answer of 0.179. It's positive, so we can say that there is a sign change between f of 0.6 and f of 0.7. So root lies between 0.6 and 0.7. The curve C2 has a polar equation r equal to theta sine theta for 0 to pi by 2. The curves C1 and C2 intersect at pole and another point Q. Find the polar coordinates of Q given the exact form. So to find out that intersection point, we can equate both the curves. They are theta cos theta equals theta sine theta. So I can bring both of them to the same side. So theta cos theta minus theta sine theta equals 0, because nothing will be there. And if I factorize, I mean if I take theta outside, I'll be getting cos theta minus sine theta as another factor. I know theta can be 0, or another possibility is cos theta minus sine theta will be equal to 0. That gives cos theta equals sine theta. We know that theta, cos theta and sine theta value will be equal at theta equal to pi by 4, and to get that point, intersection point, that will be in the form of r comma theta. So theta is pi by 4 and r is theta cos theta, theta sin theta, that is theta is pi by 4 and cos theta is, or sin theta is 1 by root 2. Since the denominator is rational one, irrational one, I have to rationalize it, so that I will be getting root 2 pi divided by 8 comma pi by 4 as answer. So the next subdivision is sketch C1 and C2 on the same diagram. So here we have that R value here, and we know that C1 and C2, if you take the table values, then you will be able to understand clearly that C1 gives a loop. Okay, so this C1 gives a loop, and then C2 gives a semicircle. So this loop will be like, and C2 will be like this point, but it can be even better. So it should intersect through this point. Then you can mention that this is C2 curve and this is C1 curve. Point is 0 and this is Q. These are the things that you can mark it. Let's move on to the next subdivision. The next subdivision is find in terms of pi the area of the region bounded by the curve C1 and the arc of OQ of C2. So we know that area formula is area equals 1 divided by 2a to b r square d theta. And here there are two curves and we have to area of the region bounded by this and that. So we can find 1 by 2 integral over 0 to pi by 4, because from O to Q it's 0 to pi by 4, r1 minus r1 square minus r2 square into d theta. You can use it. Then r1 square is, we know that it is 0 to pi by 4. It's theta square cos square theta minus theta square sin square theta. We will be getting it into d theta. After that, 1 by 2 into integral over 0 to pi by 4. Theta square can be taken as common, so that we'll be getting that inside value as cos square theta minus sin square theta into d theta. Then in the next step, I can replace this as cos square minus sin square as cos 2 theta. Then now I have to integrate by parts. So 1 by 2 into, I can take theta square as u value, so that u value is theta square and cos 2 theta is dv. So if I integrate it, I will be getting sin 2 theta divided by 2 minus, I will be having 0 to pi by 4. Now u dash value is theta. Now actually it's 2 theta, because differentiated value of theta square is 2 theta and sin 2 theta by 2 will come, that is the v value. Now this 2 and this 2 will get cancelled, and again I have to implement, I have to use integration by parts. Now theta square sin 2 theta whole divided by 2 is there, then minus theta into sin 2 theta. Here u value is theta and sin 2 theta. If I integrate, I will be getting minus cos 2 theta, so that it's going to be plus cos 2 theta whole divided by 2. I will be getting it. Then after that, I will be having minus integral over 0 to pi by 4. Then theta, if I differentiate, it's going to be 1, and sin t theta, cos 2 theta divided by 2, this value will be here. This value will be here in the integration. After that, I can write this as 1 by 2 into theta square sin 2 theta by 2 plus theta cos 2 theta by 2, and here this 1 by 2 and one more integration is going to give 1 by 2, so it's going to be 1 by 4 cos 2 theta, sorry, cos 2 theta when I'm integrating, I will be getting sine 2 theta, and that doesn't make any changes. 1 by 4 sine 2 theta will be there, and everything will be having that limit as pi by 0 to pi by 4. That's why the further simplification I can write it here, and all of them are having that denominator as 2 to 4, so that I can take 4 as common out. Already 2 is out, so that it will become 8, and the numerator is going to be 2 theta square sine 2 theta plus 2 theta cos 2 theta minus sine 2 theta. Maybe to differentiate this, I will be drawing the line here, and power, it will be having the upper bound as 0 pi by 4 and 0. So if I'm substituting 1 by 2 into, then 2 into theta square is pi square by 16, and sine 2 theta is 1, cos 2 theta is 0, so this term will be 0, and minus sine 2 theta is going to give the answer as 1. So this is for upper limit, and for lower limit these two terms are having 0 theta as the value. So when I'm substituting 0, they too will be 0, 0 plus 0 minus sine 2 0, that is also going to be 0. So I no need to worry about that lower limit. And if I simplify it further, then I will be getting 2 into pi square by 16 is pi by 8, and minus 1 I will be having it. Then pi square into 8 into 8, I will be having that answer as pi square by 64 minus 1 by 8 as the answer. So this is what the answer I'm getting when I'm simplifying it. So this answer, maybe you can use the additional page, but if I write only that the last step in the next page, maybe it will lead you to confuse, so that only I've done that answer here. So yeah, that's it. We have finished the whole paper, and we'll meet in the next paper. Thank you. All the best.